Okay, so now this is 2021 paper 3. This is where we'll begin. All right, so welcome back to another session of going through the TYS. Now, we're going to be focusing on certain questions. In fact, for 2021, we have gone through certain questions in class already. Now, let's start with question 1. Now, question 1 is clearly about oxides. The question said so, right? So clearly, this is about types of oxides. So let's revise along the way. So even before we start, let's try to categorize these oxides according to their types. There are 4 types of oxides: acidic, basic, amphoteric, neutral. So how do you know which is which? Firstly, we start with calcium oxide. Calcium oxide is basic. How do I know that? Because it's a metal oxide, right? Calcium is a metal, so it will form basic oxides. So basic oxides means they can dissolve in water to form alkaline solutions, or they can react with acids to form salt and water. So basic oxides will react with acid. Okay? Next, we have carbon dioxide. Carbon dioxide is acidic. How do you know that? Because carbon is a non-metal. Okay, so carbon dioxide is a non-metal oxide, so it's acidic. This means that it can dissolve in water to form acidic solutions, or it will react with bases. So what's the key concept here? There are 2 key concepts. The first key concept is that metal oxides are basic, non-metal oxides are acidic. That's the first concept. The second concept is that basic oxides only react with acids. Acidic oxide only reacts with bases. So you need to remember this. If I am a base, I will react only with acid. If I am acidic, I will only react with bases. Okay, so you have to remember 1 acid, 1 base. Next, we go to carbon monoxide. Now, whenever you see this word monoxide, it means it's neutral. Okay, so non-metal monoxides are neutral, like carbon monoxide is neutral. Okay, now in this list, there's another neutral oxide, which is commonly forgotten, and that's water. Now, water is a monoxide, right? If you look at the formula of water, it's H2O. It only has 1 oxygen. So it's a monoxide of hydrogen, right? So it's a monoxide, so it's also neutral. And that makes perfect sense. You have learned since Sec 2, pure water has a pH value of 7. This just tells you that pure water is neutral. So pure water is a neutral oxide. Okay. Now, neutral oxides, as the name suggests, they are neutral. It means that they do not react with acids or bases because they are neutral. Okay. So with that, we can complete the rest. Magnesium oxide. Magnesium is a metal, so it's basic oxide again because it's a metal oxide. The next 2, nitrogen dioxide and sulfur dioxide, they are acidic oxides. Okay, why are they acidic? Because nitrogen and sulfur, they are non-metals, so they form acidic oxides. Okay, so with that, I think it's quite easy to do. Now, please take note that each oxide may be used once, more than once, or not at all. So you may even have options that you never use in your answers at all. So let's answer the question. Identify an oxide which is basic. There are actually 2 oxides that are basic here, right? You just needed to choose either one of them. So you can choose either one of them. Now, those with dioxide, are they definitely acidic? If they are non-metals dioxide. That means you must have a non-metal, then dioxide. So nitrogen dioxide, carbon dioxide. Okay. So they just want one answer, so you can give either answer, okay? Next, neutral. So again, there are two examples of neutral oxides here, right? Carbon monoxide is neutral, or of course you can give water. Next, what causes acid rain? Now this one, there are also two answers. And the answer is not carbon dioxide. Carbon dioxide doesn't cause acid rain. Acid rain refers to very acidic rain caused by pollution. Okay, pollutants or pollution. Carbon dioxide is naturally occurring. So carbon dioxide will not cause acid rain, all right? The one that causes acid rain is actually the nitrogen dioxide and sulfur dioxide. But in this case, because they only want one answer, just give either one of the two answers. Okay, now if you forgot about acid rain, it's time to go back to chapter 17, atmosphere and environment. All right, our summary for atmosphere and environment, which I gave out. It's time to study that. Okay, about acid rain. Acid rain is caused by oxides of nitrogen as well as sulfur dioxide. Next, what reduces iron ore in a blast furnace? This one, there's only one answer. Blast furnace, the reducing agent is carbon monoxide. Okay, next, what is formed from incomplete combustion of methane? Incomplete combustion, carbon monoxide as well. So you can see carbon monoxide can be in fact used 3 times, B, D, and E, right? Finally, what reacts with impurities in the ore in a blast furnace to form slag? Okay, so that is calcium oxide. So in case you forgot, how is slag formed? Calcium oxide reacts with silicon dioxide to form calcium silicate. So this is slag, calcium silicate is slag. Now, because of the high temperature, it's produced as a liquid, molten slag. Okay, so let's take down question 1. It's 6 marks. Okay, for those of you who have done it, I hope you get 6 out of 6. Now, if you have gotten it wrong, you need to revise selected chapters. All right, so this is obviously acids and bases. That's chapter 10. All right. And then you have acid rain. This one is chapter 17, atmosphere and environment. Okay, same for incomplete combustion, that's chapter 17. Then you have the blast furnace, that's metals, chapter 13. Okay. So please revise these topics. As you can see, right, the first question is usually just a 1 word or 1 phrase answer, but it requires content understanding. So if your content across the different chapters is not strong yet, let's revise those chapters that you had forgotten. Okay. So if you are done and I can move on, please let me know by giving me a thumbs up so that at least I know that I can move on. Okay, thank you. Now, before I move on, just one last reminder. So the first question, right, this is like this. It doesn't need to be confined and limited to one chapter, right? You can see that in this question, we have atmosphere and environment, we have acids and bases, we also have metals, blast furnace, right? So please get used to this. Such questions need not be from one chapter only. So you must recognize keywords which tell you which chapter it's from. Keywords like blast furnace, keywords like acid rain, they tell you which chapter it belongs to. Okay. Now, question 2. Now, question 2 is actually harder than you think, but it's not impossible to do. So it's about elements in group 1. Okay, always highlight chemical names, elements in group 1. Now, what is the name for elements in group 1? Group 1, the name is also called alkali metals. Okay, So the name of the group is alkali metals. Why do we call them alkali metals? Because these are metals which react with water to form alkaline solutions. For example, sodium reacts with water to form sodium hydroxide solution, which is alkaline. This is the reason why we call them alkali metals. So because they are in the same group, they will have similar chemical properties. They will also have a trend in their physical properties. Physical properties are like what? So at this juncture, you need to know what is physical property. Physical property includes things like melting and boiling point. Includes things like density. Includes things like electrical conductivity. These are examples of physical properties which you have learned since Sec 1. All right, you learned things like melting point in Sec 1. You also learn about density in Sec 1, right? So these are examples of physical properties. Okay, things that you can measure. Okay, so now you are asked in part A to predict the melting point of cesium. Quite clearly, if you look at the melting point, the trend is that it decreases, right? The melting point decreases down group 1, which is what you have learned. For group 1, the melting point decreases down the group. Okay, and the data suggests that. So what is the melting point of cesium? Now, obviously, because it's decreasing, you need to suggest a number that is lower than the previous number. The last number here is 39 degrees, which is for rubidium. So cesium, which is below rubidium in group 1, should be lower than 39. So what number do you suggest? Any number below 39 is fine. Having said that, choose something logical, right? You are really looking at any number below 39 degrees. Having said that, a good way to do this is number patterns. You realize that the difference between every single number, okay, gets smaller and smaller. What do I mean? Okay, from 180 to 98, okay, I'm using a calculator. You are going down by 82 degrees. From 98 to 63, you're going down by 35 degrees. From 63 to 39, you're going down by 24 degrees. So obviously, the difference between rubidium and cesium shouldn't be such a big difference, right? Cesium shouldn't be like minus 10 degrees, right? It shouldn't be minus 100 degrees. Because the difference between every single element melting point is getting smaller and smaller. All right, and that's why I suggest something like 30, something reasonable. All right, don't give me minus 100 and expect me to think that it's logical. It's not logical because the difference between the melting points is getting smaller and smaller. All right. Next, part B is the challenging part. Because you need to use the information from table 2.1. Now, whenever you see this phrase, using information from table, blah, 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 or using information from graph, blah, 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 this tells you you need to quote the data. Okay, in your answer, you need to quote the data. So why is it more difficult to predict the density? Just now we predicted the melting point one. Why is density harder to predict? Well, let's look at the numbers. If you look at the density, from lithium to sodium, it increases, right? But what happens when you go down to potassium? Potassium, the density is decreasing. From sodium to potassium, the density decreased. So do you think the trend is consistent? Do you have the same trend, which is it increases down group 1 or it decreases down group 1? You can't say that, right? Because there's no trend. From lithium to sodium, the density increases. But from sodium to potassium, density decreases. So there's no consistent trend, and therefore it's harder to predict the density. So how do you put this into words with the data? the best way to do this is to say that from lithium to sodium, the density increases from 0.53 grams per cm cube to 0.97 grams per cm cube. However, from sodium to potassium, the density now decreases, right? From 0.97 grams per cm cube to 0.89 grams per cm cube. There is no consistent trend in density down group 1. So it is difficult to predict the density of cesium. Okay, I know it's a lot to write for 1 mark, but imagine that this question was worth, say, 2 marks or 3 marks. This answer will still be complete, even if it was 3 marks. You noticed, right? The way I've done this is to quote data. And to quote data means I try to use examples. I pick pairs of elements to look at, from lithium to sodium, then from sodium to potassium, quoting the numbers and showing that there is no consistent increasing trend or decreasing trend. Okay? Now, this question is challenging for combined science, so I would advise us to learn the skill of reading data and using it in your answers. Okay? Now, I'm just going to move quickly on to C and D. State one other physical property of cesium. Now, other means cannot repeat density, cannot repeat melting point, all right? Well, a good physical property to remember, all metals, including cesium metal, it must be a good conductor of electricity, right? So all metals are good conductors of electricity. That is one good property to remember. Otherwise, you can also try to remember group 1 metals, the alkali metals are very unique because they are very soft. They are very easily cut. All right, so this is quite unique to group 1. All right, next, D part 1, suggest why sodium is in period 3. This one I think we have gone through many times. It has to do with electronic configuration, right? The electronic configuration of sodium is 281. So it has 3 filled electron shells. So it is in period 3. So most of you would think, I thought I just need to say 3 filled electron shells. Why do I really need to write 281? Now, it's only 1 mark. So if you just wrote 3 filled electron shells, you would have gotten the 1 mark. However, imagine if this question was 2 marks, then you should try to write out the electronic configuration. Okay? Next, finally, write the balanced chemical equation for the reaction between sodium and cold water. That's what I mentioned just now. They are called alkali metals because they react with water, cold water, to form alkaline sodium hydroxide solution. Then they must produce a gas as well. Metals always produce hydrogen gas. Then you must balance the equation. Okay, so you can see it's 3 marks are standard. How do you allocate the 3 marks? The first mark is always the formula. Formula of the reactants and products correct. The second mark is the balancing. The third mark is the correct state symbols. All right, 3 marks. As you can see, this is 7 marks in total. It is not difficult to score these 7 marks so long as you understand group 1. So if you have forgotten group 1 chemistry, it is time to revise from our summary notes for chapter 13, the periodic table. Oh, sorry, chapter 14, the periodic table. All right. Okay, So once you are done copying, I may move on. Please let me know via a thumbs up so that I know that I can move on. Okay, thank you. By the way, right, I hope you also copy down the star. When I put a star, it's because I think the skill is important. And when you flip through your TYS later on, when you revise, let's say tomorrow morning, you should try to revise the start questions because those have skills that you should learn. Okay, and try to remember. The same question is unlikely to come out, but the skill of quoting data may come out, right? So you must learn the skill of quoting data. Okay, it's a bit like how you all do English comprehension. You don't lift the whole passage out, right? You have to choose selected phrases that help you to illustrate your answer. Same here. You don't quote all the data. You quote specific pieces of data that allow you to explain your answer better. Okay? Okay, great. So I will move on. Now, question 3 is not difficult, right? As you can see, oh my gosh, this fermentation thing is 3 marks. Okay, so imagine if you didn't study fermentation, you would have thrown the 3 marks down the drain. But now that you have studied fermentation, you probably would be able to do this very, very well. So let's just quickly do this. State the number of atoms in 1 molecule of ethanol. Atoms, right? This one you have learned in Sec 1, okay? And it's not difficult, but students can still get it wrong. Why? Because they always confuse words like atoms and electrons and ions and molecules. What are atoms? Atoms are these individual things that you see. There are 2 carbon atoms. There are a total of 6 hydrogen atoms. There's 1 oxygen atom. All right. So these are atoms. So what is molecule? The whole thing is a molecule of ethanol. Molecules are formed when your atoms, your non-metal atoms, share valence electrons and form covalent bonds with each other. So the molecule is the whole unit formed after covalent bonding, after sharing of valence electrons. Okay. So if you have forgotten what's atom, what's molecule, where do you go to? Please go back to my chemical bonding and atomic structure summary. Okay. Now, the next careless mistake here is that many students will forget hydrogen. Please count properly. There are not just 5 hydrogens. There's 1 more hydrogen here. So that's 6 hydrogens in total in the molecule of ethanol. So with that, you have 2 carbons, 6 hydrogens, and 1 oxygen atom. So if you add together, that's 9 atoms in total. Okay. Next, ethanol is manufactured by the fermentation of glucose. Briefly describe this process. Now, describe means you have to really explain already. All right. So the best way to do this is to start with conditions and substances needed. So I start with conditions first. The conditions needed are 37 degrees Celsius and absence of oxygen. This one we went through yesterday. The substances needed, obviously, glucose solution, and yeast. All right. So writing this down would easily secure you, okay, 1 mark already. Okay. Now you need to briefly describe this process, meaning you need to explain why 37 degrees, why absence of oxygen. The temperature of 37 degrees Celsius is the optimum temperature, or you can say the temperature at which the enzymes in yeast work best. Okay, so optimum means the temperature at which the enzymes work best. There's maximum enzyme activity. So that's explaining temperature. Why is absence of oxygen needed? Absence of oxygen is needed in order to prevent oxidation of ethanol to ethanoic acid. Okay, now I would say that this is probably enough for the answer for this question. Number one, because only 3 marks. Number two, you only need to briefly describe. But if you want to talk about how much ethanol you get, you can also go on. If you remember, the yield of ethanol is about 15 to 20% as high concentrations of ethanol would kill the yeast. Okay. Now, finally, many students probably forgot this one. How the ethanol is purified. Now, this is something that is not within the 5 marks that I have given in your notes. However, I mentioned this before. How do we purify things in organic chemistry? In general, in organic chemistry, what separation or purification technique do we use? You have learned a few, right? You have learned filtration, evaporation, crystallization, and so on. So which technique is commonly used in organic chem? Let's ask someone. Nafil, which technique of separation and purification do we use in organic chem? Nafil, are you there?
So can you repeat?
What technique of separation do you use for organic chem?
For organic chem.
Yes.
Fractional
Complete the sentence. Fractional what?
distillation.
Yes. Okay, now fractional distillation is not just for crude oil. Fractional distillation is for any mixture that contains 2 or more miscible components that have different boiling points. Miscible means they mix together. Different boiling points, you understand, right? They boil at different temperatures. So this is commonly used in organic chem. Because fractional distillation can be used for things with different boiling point. Okay. In organic chem, very often you will have substances with different boiling points, and that's why fractional distillation is used. If in future you go on to study more chemistry, you may go into say perfume chemistry. Perfumes are made of organic chemicals as well. Okay, so how do you actually purify the perfumes? You have to use fractional distillation, and that's why perfume chemists will have to spend a large part of their time just doing fractional distillation. Okay, so remember, our organic chem, fractional distillation is the common purification technique. Okay, finally, the next one. Ethanol is oxidized by oxygen in the air to form ethanoic acid. Draw the full structural formula of ethanoic acid. Okay, please. Yesterday, we have careless mistake in 2016, right? They tell you to draw propanol, you're going to draw propanoic acid. Now, what they want you to draw? They wanted you to draw ethanoic acid. So please don't draw the wrong thing. Draw the correct thing. Now, where do you start? For organic, always start with the functional group. It's a carboxylic acid. The functional group is COOH. Always start drawing the functional group first. Then draw the number of carbon atoms needed. Ethanoic acid. Eth means 2 carbons. So I draw 1 carbon already. Remember, there's already 1 carbon in the COOH functional group. So you only need to draw 1 more carbon. Okay? So please don't be tricked. Carboxylic acids, you must be careful because there's already 1 carbon atom in the functional group. Then you just have to complete the blanks and ensure that every carbon atom has 4 bonds around it. Okay, so that's the structural formula of ethanoic acid. Okay, now once we are done, let's go to 3D. 3D is quite challenging. All right. Okay, 3D is quite challenging. So let's look at 3D once we are done. Okay, just a reminder, there is a double bond here to oxygen. So the COOH, one of the bonds is a double bond. The bond to oxygen is a double bond. So please learn this functional group well. This is the functional group for carboxylic acids. Okay. Okay, let's go to 3D. Now, D is quite challenging. Because what they have given you is the general formula for alcohols. This one you learn, right, by heart. But this is for saturated alcohols. Means there is no carbon-carbon double bond. If there's no carbon-carbon double bond, it will have the general formula CnH2n plus 1 OH. So now they give you a compound. This compound has C7H13OH. Is this saturated or not? That's what they want you to deduce, right? How do you know? Obviously, you must make use of the general formula, right? That's the purpose of giving you the general formula. Does it follow the general formula? So let's take a look. It's C7H13OH. So now let's try to work out the numbers. There are 7 carbon atoms. So N is 7, right? 7 carbon, so N equals to 7. So if I follow the formula, it should be C7H, 2 times 7 plus 1, OH, right? If it's saturated, it should be 2N plus 1, 2 times 7 plus 1. What is 2 times 7 plus 1? So you work it out. 2 times 7 is 14. 14 plus 1 equals 15. It should be C7H15OH. Then this is saturated. But let's look at our compound. Do you think our compound is 15 hydrogen? Is it C7H15OH? No, right? The compound given to us is C7H13OH. So now, can you now conclude? Is it saturated or is it unsaturated? So let's ask someone. Okay, Ethan, would you like to tell me, do you think the compound given to you is saturated or unsaturated?
Unsaturated.
Unsaturated, right? So let's write it down. C7H13OH is unsaturated. If it's unsaturated, it means it's not a saturated alcohol. Why? Because it does not follow the general formula CnH2n plus 1 OH. Okay, actually that's all that is needed for this question. Because it's only 1 mark and it's just a deduction question. Okay. Now, even though the answer needed is just this, let's challenge our understanding a bit more. So obviously it's unsaturated, right? It's not saturated means it's unsaturated. Unsaturated means it has a carbon-carbon double bond. How many double bonds do you think this compound has? I repeat the question. How many double bonds do you think this compound C7H13OH has? So think about it. How many double bonds does it have? Okay, let's get someone to hazard a guess. Okay, I see Nafil and Irfan. So just now Nafil answered, right? Now Irfan can answer. Irfan, how many double bonds, carbon-carbon double bonds, do you think this compound given to you has?
I think 3.
3. This is 3?
3, yeah.
Okay, how do you guess 3? I'm curious.
One double bond with 2 carbon, and then got 7. So
Oh, so you go by the carbon atoms, right? Oh, okay. But actually, right, does it work? So we have seen before, right, in your alkenes, right? Alkenes, right, actually they only have one double bond, right? The number of carbon atoms may not tell you how many double bonds it has. For example, alkenes, right, you can have like 3 carbon atoms, but only 1 double bond. So it doesn't mean that 7 carbon atoms must have 3 double bonds, okay? So a fun, good guess, but not correct, okay. So Leon, do you want to say something? Or is that Jonathan next to you?
Sorry, I say it on the mic.
Okay, since you're on the mic already, Leon, why don't you guess? So Irfan tried to look at the carbon atoms. That doesn't work, right? Let's look at the hydrogen atoms. From the hydrogen atoms, we can tell how many double bonds there are actually. So Leon, would you like to guess how many double bonds between carbon are there?
So can you repeat?
How many double bonds are there? If you look at the hydrogen atoms. Okay, make a guess. It's not 3 double bonds. How many double bonds are there? 1. Why? How you know? How you know there's 1 double bond? Leon?
Huh?
How you know it's 1 double bond?
How you know?
Is Jonathan giving you the answer now? All right, it has 1 double bond, okay, within carbon atoms. Okay, hi, Miss Ng. Okay, now it has 1 double bond. Now, every time the number of hydrogen atoms decrease by 2. Every time the number of increases by 2 in the formula, that means there is 1 carbon-carbon double bond. Okay. Now this one I don't expect you all to remember. I don't expect you to remember, and neither does the examiners expect you to remember. But it's a good thing to learn, especially if you are quite strong already. Actually, you realize this is the case, right? If you don't think about alcohols, you think about something simpler. For example, you think of alkanes versus alkene. Alkane, alkene, right? Alkane, you have learned. The general formula for alkane is CnH2n plus 2. Right? This alkane. Alkane is saturated. Don't have carbon-carbon double bond. How about alkene? Alkenes have 1 carbon-carbon double bond, right? That's what you have learned. What's the general formula for alkenes? CnH2n. So let's look at the H. Doesn't it differ by 2? So it decreases down by 2. You will have 1 double bond. Okay? Can? So this is a pattern that you learn. All right, so I'm just going to leave it here for a while for you to take it down quickly. And then we'll go on to question 4 very quickly. Question 4 is very short, so I'll finish it very fast. Okay? So once you have taken down, can you give me a thumbs up so that I know you are done? Okay, thanks, Fala. Okay. Leon, you are applauding. Okay.
So I pressed the wrong emoji.
Okay. All right, great. Okay, so this is an important pattern. Hopefully you have realized it. But of course, don't memorize this, okay? You should be able to deduce this. Okay, let's move to question 4 now. Question 4, right? 2021, which is last year, tested like that. They asked them for the name of the reaction. Okay, this is not difficult. Most of you definitely can do this, right? If I write out the answers quickly, I'm sure you know. The first one is cracking, right? converted into smaller alkenes. The next one, acid reacting with base. This is neutralization. I think you are familiar with this already. Next, takes in energy from surroundings. Energy changes, take in internal, endothermic. Next, two solutions react to form an insoluble solid. Keyword, right? Insoluble solid, keyword. Forming insoluble solid, that's called precipitation. Finally, the oxidation state of an element increases. A oxidation state, increase, oxidation. Okay, now the last one, you must write oxidation. Now it's not redox because it's very specific here. They have said the oxidation state increases, so there's oxidation. Okay, Ken? So I'm sure these are not difficult for you. I'm sure most of you have realized this. Okay, now let's just quickly revise cracking. What are the conditions for cracking? So cracking, the conditions needed, what temperature do you need? 600 degrees Celsius. So you got to remember, cracking 600 degrees Celsius. And the catalyst is aluminium oxide or silicon dioxide catalyst. So that's for cracking. All right. So if you have forgotten, can you please take this down quickly? Now, just now we talked about fermentation. Fermentation of glucose, temperature is 37 degrees. Okay, you need yeast. How about another reaction? Hydrogenation. Remember, hydrogenation is when you add hydrogen to alkenes, right? Hydrogenation is another important reaction you must learn. What are the conditions for hydrogenation? Again, you have certain temperature, right? Hydrogenation, what is the temperature required? Let's ask someone. Okay, C-Dash, would you like to tell us what is the temperature needed for hydrogenation of alkenes?
Is it 600?
600 is for cracking, so it's some other 100. Would you like to try again? Not 600.
400?
Okay, lower. Not 400, lower.
Don't say 200. 600.
Okay, 200. Okay, 200. Now,
Okay.
so hydrogenation, temperature needed is 200 degrees Celsius. The catalyst you need is nickel. Do you need to remember this? Well, these are the conditions needed for the specific reaction. It's like remembering a recipe. What temperature do you bake your cupcakes at? Similarly, what temperature would you carry out hydrogenation of alkenes? Now, how is hydrogenation of alkenes useful? Hydrogenation is used for making margarine from vegetable oil. So you do need to know this, all right? So let's take it down. Cracking is 600 degrees, aluminum oxide or silicon dioxide catalyst. Hydrogenation of alkenes used to make margarine, that is 200 degrees Celsius, and nickel. That's the reason why I wanted to go through this. So that at least you're familiar with the conditions needed. If you think that you might forget, okay, if you think you might forget, please make sure you go through, all right? Again, be it tomorrow morning or be it tonight. Now, where do you find these things? You can find these things inside my notes, summary notes, all right? You can also find it in the alkanes and alkenes notes, okay? So that was question 4, which allows us to revise the conditions needed for different reactions. Now, question 5, I'm just going to quickly go through it. Same with question 6. I will just very, very quickly give you the answers. All right. Okay, let's move on to question number 5. Now, question 5 is salt prep. Okay, I'm sure by now you probably know salt prep already. So you are preparing magnesium sulfate here. Always highlight chemical names because that will tell you what the starting materials could be. So in this case, they told you that magnesium oxide is prepared from an insoluble base and an acid. And the insoluble base used is magnesium hydroxide. So what is the acid used? You are forming magnesium sulfate. So the acid clearly has to be sulfuric acid. Next, explain why excess magnesium hydroxide is used in stage 1. Why do you always add excess solid carbonate, excess solid metal, excess solid base? Why do you add excess? It is to ensure all the sulfuric acid, all the acid is completely reacted so that the salt form is not contaminated. So I think we mentioned this before. The purpose of adding excess solid is so that all the acid reacts away. So your salt form at the end of the day doesn't have acid on it. Next, explain why the mixture is stirred and warmed. Now, this is quite commonsensical. Why would you stir something or warm something? It is to ensure that the magnesium hydroxide, the base, in this case is magnesium hydroxide, reacts with the sulfuric acid more quickly. It is about speed of reaction. It is to increase the speed of reaction, ensuring that the base reacts with the acid more quickly. Okay, so up to this stage, I think it should be quite okay. Okay, so we say goodbye to stage 1. Now we go to stage 2. Now you really have to read. Stage 2, the excess magnesium hydroxide is separated from the aqueous magnesium sulfate. So you need to know that the magnesium hydroxide is insoluble solid, right? How would you separate a solid like magnesium hydroxide from an aqueous solution of the salt? The method you use to separate out solids is always filtration. You will use filtration to separate out sand from water, because sand is an insoluble solid. So similarly, over here in this reaction, magnesium hydroxide is a solid, so you use filtration as well. Finally, let's go to stage 3. Aqueous magnesium sulfate is left to crystallize. Name the physical change that occurs to water. Many students just memorize crystallization, but is that the answer? Read the question carefully. You are asked to name the physical change that occurs to water, you know. The water doesn't crystallize. The magnesium sulfate crystallizes. So what happens to water? Water doesn't crystallize. So what do you do with the water? The water evaporates, right? When you leave the solution out in air, the water will evaporate away, and that leaves behind the crystals of magnesium sulfate. All right. Same, when you are heating a solution until it's saturated, what you are doing is that you are evaporating the water away. Okay. So the physical change is evaporation. Now, the difficult one is actually the last part. Many students got tricked. They just wrote down crystallization, which is wrong. You are not crystallizing water. You're evaporating the water. All right. So that is question 5, salt prep. So if you have lost marks here, you need to revise salt preparation again. Now, question 6. Let's quickly go on to question 6. Now, question 6 is about paracetamol. I'm sure you know what paracetamol is. The common trade name for paracetamol is Panadol. That's what you take as a painkiller. It also helps to reduce fever. All right. Now, paracetamol is a drug, it's a medicine. Okay, how would you know that the 3 samples are all impure? Well, it's quite obvious, right? Purity has to do with the melting and boiling points. If it's pure substances have a fixed melting and boiling point, meaning it should melt at a fixed temperature, 1 temperature. But look at the melting points here. The 3 samples do not have a fixed melting point. How do I know the melting point is not fixed? Because they melt over a range of temperatures. Right? They melt from, let's say, 165 to 167 degrees Celsius. That's a range. It's not just one temperature that's fixed. Okay, so that's part A. Part B, use the kinetic particle theory to describe the changes in the movement and arrangement of particles during melting. How do you answer this? So we have gone through this in the kinetic particle summary previously. So how do you describe changes? You must always start with the original state. What's like? The final state, what is it like? So the movement of particles changes from vibrating about fixed positions. That's the solid state, right? It started as a solid. So at first, the particles were vibrating about fixed positions to sliding past one another freely or easily. So this is about movement, all right? Similarly for arrangement. Arrangement is about packing. Is it closely packed? Is it regular? So the arrangement of particles changes from closely packed in a regular manner to closely packed in an irregular manner. Okay? So when they ask you for changes to the arrangement and movement, I hope you realize that this is the format of answering. Start with the original state, then what state does it go to? Okay? All right, finally, part C. Now, part C is a common sense question. Having said that, not so common sense nowadays, right? Now, why is it so important for medicine, for drugs, to be tested for purity? Why is it so important to do all these tests in the first place? Why? Why must your medicine be pure? Well, think about it. If your medicine is impure medicines or drugs, do you think they are safe to consume? Clearly not, right? Impure drugs can be dangerous to health, as the impurities could be toxic. Okay, this is quite obvious. Impurities can potentially be toxic. So after taking the impure drug, the person might suffer an adverse allergic reaction sometimes. The person may suffer from very severe side effects caused by the impurities because the impurities may be toxic. Now, I'm going to give you an example of this. Later on, after the lesson, use your iPad to go and Google this particular drug. Okay, this was a drug that was prescribed to pregnant women to help them with the vomiting. Pregnant women frequently feel nausea. Okay, so actually scientists, doctors came up with this drug and gave it to pregnant women. The problem though was they gave it to pregnant women without testing for the purity of the drug. So as it turned out, there were impurities in this drug that was sold at the pharmacy. And millions of pregnant women took it without knowing that there were impurities that were toxic inside. As a result, many of the babies born at the end of the day had birth defects. They were actually missing a few fingers, or they were missing organs, and that was caused by the impurities present in the drug. And that was the reason why now all your drugs have to undergo very stringent tests to ensure that they are pure, to ensure that they are safe for human consumption. All right, so later on, you can go and Google this drug later on after the lesson. Okay, that was question 6. May I move on? If I may move on, please give me a thumbs up, so that I know that you're there as well. Okay, I know it's tough. Okay, it's a long lesson today, but let's persevere. All right. Okay, now question 7 is on QA. Okay, and question 7, I don't think it's very difficult because they actually told you that it's barium carbonate, right? So question 7, you are even told it's barium carbonate at the start. So I think it's quite straightforward. R, S, T are so obvious. T is carbon dioxide, because the carbonate must give you carbon dioxide gas. Okay. R, the liquid must be water. S is barium nitrate. Okay. Can? So RST, I think are not difficult. Now, after that, you add sodium sulfate. Sodium sulfate, no. Barium nitrate is a test for sulfate, because if there's sulfate, you will form a white precipitate. So what is the white precipitate? Barium sulfate is the white precipitate, U. Finally, the next one, colorless gas that turns damp red litmus paper blue. This is ammonia gas. Okay. Writing the balanced equation, please always write the acid reactions. Acid reactions are simpler. In this case, barium carbonate plus nitric acid forms barium nitrate plus CO2 plus H2O. Balance the equation. That's it. All right, so by now you should realize that acid reactions are quite easy to write, so long as you know the reaction itself. Okay, by now you should also be able to predict what is the charge that different ions would have. Barium, for example, is in group 2. So barium is group 2, just like magnesium and calcium. So it will lose 2 valence electrons to form Ba2+. Okay, so that's QA. Now, Mr. So will just be going through questions 8, 10, and 11. Question 9, I think we have gone through in class before. Okay, so may I move on? If I may move on, give me a thumbs up so that I know that you're done with the QA question 7. Okay, now question 8, I will skip the mole concept because I think you can do this yourself. All right. Okay, so I'll skip 8A. Let's go straight to 8B and C. All right. Now, give the meaning of the term alloy. Now, this is one of those questions that will throw students off course because they didn't memorize the definition, right? But actually, the definition for alloy is very simple. Alloy is just a mixture containing a metal and other elements. Okay, so alloy must have at least one metal and other elements. Now, the other elements could be a metal, could also be a non-metal. And the keyword here is mixture. So alloys are mixtures. Okay, so alloys by definition are impure. They are not pure. They do not have a fixed melting point. So for example, steel is an alloy. Steel contains iron and carbon. Okay, so steel is a mixture of iron, metal, and carbon. Now, steel is impure, therefore steel doesn't have a fixed melting point. Now, what are other examples of alloys? You also have other things like brass. Brass contains copper and zinc. Brass is an alloy that's commonly used to make musical instruments. So for example, for those of you who were in band, your trombones, your trumpets, okay, even clarinets, they are commonly made using brass. Why do we use brass and not copper metal? Because brass is stronger and harder, so your musical instruments will last longer. Another common alloy is bronze. Bronze is commonly used to make medals, right? Your bronze medal. Bronze contains copper and tin. All right, so these are the three common alloys which I think you should try to learn. Okay. Okay. Ken? Okay, so let's move on. Let's go straight to question 10, because question 9, I think we have gone through in class before, briefly. Okay, as you can see. Now, question 10, we have actually gone through parts of it. But let's start with question 10A. All right, so you're given the structure of ethene, and you're asked to use the structure of ethene to explain why it's unsaturated. I think this is easy, right? Ethene is unsaturated because it contains a carbon double bond. Okay, next, describe a chemical test that can be used to show that ethene is unsaturated. Please don't add aqueous bromine. It's not add aqueous bromine. Ethene is a gas. You need to bubble ethene into aqueous bromine. All right. Why do we bubble ethene in? Because it's a gas. All right. Ethene decolorizes aqueous bromine from reddish brown to colorless. Okay, so this one is standard. It's a standard chemical test to prove that something is unsaturated. Okay, so I think I've drawn ethene for you as well previously, the dot and cross diagram. So like I mentioned, for anything that is organic chem related, always start with the structural formula. That means you draw out the bonds first, so that at least you know that, oh, there's a double bond between the carbon atoms. Okay, so for organic chem, don't straight away draw the dot and cross. Draw the structural formula first. Then from the structural formula, you translate into dot and cross. So Ken, once you know there's a double bond, then of course you know there's dot cross, right? Between the carbon atoms. Okay, so I think we have gone through this before. If you are still unfamiliar with the dot and cross diagram for organic molecules, please rewatch my video, Organic Chemistry Summary Part 2. Okay, it's on YouTube. Okay. Now let's go to D part 1. Okay, I think I've gone through that before in class also. Okay, draw 2 repeating units of polyethylene. Ethene is easy, right? 2 repeating units. How to draw? This is 1 repeat unit. How do you draw 2? Just repeat lah. Oh. So this is 2 repeat units of polyethylene. Next, state uses for polyethylene. Now this one is difficult because most students never go and study this part of the syllabus. Now, how can polyethylene be used? Polyethylene is commonly used to make plastic containers. Otherwise, it's used for plastic bags. Okay, don't just write plastic. At least tell me it's a container or a bag. Okay, next, describe some of the pollution problems caused by disposal of polyethylene. Please don't just write that it causes water pollution. That is so not specific. Give details, all right? Can? So give details like what problems will be caused. So first, always mention that the polymer, polyethylene, is non-biodegradable. All right, polyethylene is non-biodegradable, so it will remain in the environment for a long time without breaking down. All right, hence it will accumulate in landfills and oceans, causing land and water pollution. If you look at my answer, it gives details. I started off by explaining that it's non-biodegradable, so it will accumulate in the environment for a long time, in your landfills or in the oceans, which can cause land and water pollution as a result. Okay, so don't just go straight to saying water pollution. How? Give me the examples. Okay, same for the previous part. Don't just say things like it can be used for carrying stuff. Polyethylene is a plastic container or plastic bag. That's why it can be used to carry stuff. Okay. So that's question 10, which is on polymers. As you can see, every year there's one of these questions on the environment. Okay. Recycling. Why must you recycle your plastics? Why must you recycle your metals? Like yesterday we went through, right? So similarly over here, they ask you about the pollution problems that can be caused by disposal of plastics. Okay, so that is question 10. So once you are done, give me a thumbs up so that I know you can move on. Okay, good. By the way, for D part 3, right? Are we marking word for word? Must you write 100% identical to Mr. So? No, you don't, right? Of course you don't. But the broad idea must be there. Broad idea means you must have the concept that the plastic is non-biodegradable. You must have this concept that because it is non-biodegradable, it will remain on land and in the ocean for a very long time. Okay, so the idea must be there. Okay, so even if your answer is slightly different, that's fine, so long as you have provided these ideas and concepts. Now, let's go to question 11. Question 11 is one of those questions that I'm sure students will immediately laugh when they see the paper. Because it's so easy, right? If you look at A part 1, you just needed to write the mass, the relative mass, and the relative charge of electrons, protons, and neutrons. These are things that you have learned even in Sec 1. However, the simpler the question is, the more likely you are to be complacent. So don't be complacent. Some of you, actually you know the answer, but you wrote the answer in the wrong column or the wrong row. For example, the mass of an electron is 1/1840 or 1836, right? This is the correct answer. You must write it here. Some of you will just misread and write this somewhere else. Then that's wrong, lor. Okay? So the relative mass of an electron is 1/1840 or 1836. The relative charge, of course, is 1 minus. Electrons have a negative charge. Protons, relative mass of 1. Relative charge 1 plus, given to you already. Neutrons, mass is 1, charge is 0. Okay, next. Counting the number of each particle in the isotope of bromine. This one also very easy. Most students, wow, no problem, easy. However, That's when the careless mistakes come in, right? Please read carefully. Hello. You must give electron first, then proton, then neutron. Proton is 35, it's the smaller number. Electron, same number as proton because it's atom. Atom, the proton equals to the electron in the number. Okay, so also 35 electrons. Neutrons. How do you get neutrons? You must take the bigger number minus the smaller number. 79 minus 35 gives you 44. So this is where all the careless mistakes will come in because you are so confident that you misread stuff. So how do you avoid this? Read slowly, highlight or underline the keywords. All right? You don't want to be making careless mistakes like these, because this is actually quite straightforward. I'm sure you know how to do it. Okay. Now, this is the answer if we are looking at the atom of the isotope. Now, what if the question was changed to ion of the isotope? So this is the isotope, right? What if I didn't want the atom? What if I wanted the ion? So now you're going to think, okay, what is ion? Ion means there's charge. It's formed by the loss of electrons. So you're going to think, bromine. Bromine, does it lose or does it gain valence electrons? So let's ask someone. Okay, Eileen, does bromine lose or gain valence electrons?
Gain electrons.
Gain valence electrons, right? How many does it gain, Eileen?
1.
1. And we know that it gains 1 valence electron because it's from group number 7. So it will gain 1 valence electron, right? So when you gain 1 electron, what happens? At first, you must have 35 protons, right? Protons will not change because you never lose or gain protons. But now you think, will the ion still have 35 electrons? No. As Eileen told us, it must have gained 1 valence electron. So at first, you got 35 electrons in the atom. Now in the ion, you must have 36. Why 36? Because gained 1 valence electron. So this is the important part. If I want ion, you must think whether electrons are lost or are they gained. Okay, you must think about loss and gain of electrons. Okay, the neutrons unchanged is 44 as well. Okay, now why am I saying this? Because you must read the question carefully. In 2021, they tested the students on atom, right? But what if you are tested on ion? Then you must be prepared to deal with this added complexity where you have in is group 7. Group 7, 7 valence electrons. You will gain 1. Gain 1 electron, therefore it becomes 36 electrons. Okay? Now the rest is quite straightforward, okay, except part 3. Part 3 is again another challenging part. Now part 3, an atom of another isotope of bromine has twice the number of nucleons as one atom of calcium. Many students didn't know what nucleons were. A nucleon is just the bigger number, you know. The bigger number is called the nucleon number. All right? So like in the case of calcium, 40 is the nucleon number. Okay? The nucleon number is also known as the mass number. So 40 is the nucleon number of calcium. Now, if it has twice the number of nucleons, means this bromine isotope will have 80, right? Twice of 40 is 80. So the nucleon number of this isotope is 80. The proton number won't change. The proton number must still be 35 because isotopes have the same number of proton. So how many neutrons? The number of neutrons will be the bigger number, 80 minus 35, which gives you 45. So this one challenging because many students didn't know what nucleons meant. Nucleon number is just the bigger number of the two numbers, okay? So twice the number of nucleons, twice of 40, that's 80, okay? Can? Okay, now just give me a minute as I try to connect up my charger because I'm running out of battery on my laptop as well. Okay, in the meantime, please ensure that you have copied everything down. All right, moving on to part B. Now, potassium bromide is an ionic compound. It contains K plus and Br minus, right? So this is exactly what we talked about just now, Br minus. Bromine gains 1 electron to form Br minus. So describe the formation of K plus ions from potassium atoms. In terms of electron configuration, this is a hint to you that your answer must have electron configuration inside it. If you didn't write the potassium atom 2881, if you didn't write 2881, no marks, you will lose marks because this is what we mean by electronic configuration. So potassium, you go to the periodic table, you look, the electron is 19. 19 is 2881. So if it's 2881, it will lose 1 valence electron to form K plus ion. Now after losing 1, 2881 will become 288, right? But that's not the end. You must explain how come it loses 1. Why does it lose 1 valence electron, not 2, not 3? Because the ion will now have a fully filled outermost electron shell. Okay, so this is the purpose. It is to achieve a fully filled outermost electron shell by losing the valence electron. Next, state 2 physical properties of potassium bromide. They are asking you about potassium bromide. This is an ionic compound. They have told you it's an ionic compound to help you. So they are asking you for the properties of ionic compounds. There are 2 main properties which you have learned. First, high melting and boiling points. So ionic compounds will have high melting and boiling points, and that is because a lot of energy is needed to overcome the strong electrostatic forces of attraction between the ions. Next is about electrical conductivity. Potassium bromide does not conduct electricity in the solid state. But conduct electricity in the molten and aqueous states. Okay, so this one you should also be familiar. The explanation as well. In the solid state, the ions are held in fixed positions and are not free to move. Whereas when molten or dissolved in water, there are free moving ions that can conduct electricity. Now, there's a third one that you can write. It is soluble in water. Now, ionic compounds are generally, most ionic compounds are soluble in water. Same as potassium bromide. Potassium bromide is definitely soluble in water because it's a spar salt, right? Spar salts, sodium, potassium, ammonium salts are all soluble in water. Okay, so with that, we have finished going through the 2021 paper 3. Okay, so I hope this has been useful for you, okay, to reconsolidate all these concepts. Now we're going to start at 340, so that you have about a 12-minute screen break. So please feel free to stay in this Zoom room and I will stop this recording here.